8:30 according to me, so let's get this show on the road. Welcome along to this presentation on Splunk as a big data platform for developers. Some of you may already be using Splunk, some of you may already be customers, some of you may just be tinkering around with it, and some of you may never have heard of Splunk before, so hopefully we can cater for all of you guys this morning. Just a little bit about who I am. I'm the developer evangelist at Splunk. It's a very holy title, but basically it means that I'm really passionate about building big data apps on the Splunk platform, and I'd like to share that passion with you guys. And also I get to wear really cool t-shirts for a living, which is kind of nice. Before joining Splunk, I was an active member of the Splunk community, and I kind of got hired out of those ranks. So we have a very thriving Splunk community where people can contribute and develop and share answers and questions together over on Splunk Base, and I was involved in building a few apps which people were using and downloading for free. I also had a day job where I got paid, and funnily enough I was being a Splunk admin and an architect in that role as well. And prior to this I'm kind of a lifelong coder. I've been cutting Java code and a bit of Groovy code and Scala code kind of most of my career, and it's paid most of my mortgage. I put in this little bit of self-deprecating humor down the bottom here, but hanging out at this conference all week I realized that most people here have accents. Well, so do I. I'm from New Zealand, so if you've got any funny New Zealand jokes, just save them for the pub later on and buy me a beer and heckle away. So what I'm trying to cover today is I'm just going to take you on a bit of a journey with Splunk, from just the basics as to what Splunk actually is, for those of you who might be brand new to this thing you've heard about. Then I'm going to move through to how you can actually use it as developers for building your big data apps. Talk a little bit about our Java SDK in particular. We have many language SDKs, but because it's a Spring and Groovy conference, I figured Java was the most relevant to talk about. And talk about some new Spring integration extension adapters we've built, which are brand new and hot off the press. So I'll show you some of those, and we'll have some live interactive demos to show you there. And if we've got a little bit of time, just some other cool little kind of JVM Java related tools in the Splunk family there. And a bit of question time at the end. If there isn't time for all your questions, we've got a booth outside, so just come and grab one of us and ask away. So, what is the Splunk thing? Well, basically, Splunk is an engine for machine data, for aggregating, collecting, correlating, then searching over all this machine data, then ultimately using it to acquire some sort of visibility into whatever environment that you're extracting all this machine data from. We don't require that all this machine data is schemarized in the traditional sense of maybe an ETL scenario with extract, transform, load. Most machine data these days is completely unstructured. So we can just fire all of this disparate heterogeneous machine data into Splunk and make sense of it on the fly. You can download Splunk and use it entirely for free. You can set it up on your laptop in 5 minutes, and you can just use all the enterprise features entirely for free. It's going to run on most platforms, Windows, Linux type platforms. And it's got an incredibly open and extensible architecture. It's not going to lock you into a black box style approach. If you need to customize it for something to you can open it up and extend it to your heart's content. And that's actually one of the things that attracted me to Splunk in the first place. Coming from being a Splunk customer now to being a Splunk employee, I was just very, very much attracted to be able to customize it and write my own extensions to the product as I needed it to suit my environment. So I mentioned before, it indexes any machine data. I think, 80% of all the data that's been generated today is completely unstructured, coming from a variety of machine sources. You've got your kind of traditional machine data, it's log files and things like that. But if you really think about it, everything is generating machine data these days. You've got your operating system metrics, you've got your various management and monitoring APIs of systems. You've got traditional kind of syslog coming out of your network devices. You've got your social media feeds. Embedded devices are emitting machine data. My power meter at home is emitting machine data. My toaster is emitting machine data, if you really want to get funky about it. You can sniff network packets off the wire and decode those and roll those out, and that's useful machine data. This stuff is everywhere, basically. So that's what Splunk is doing, it's indexing all this heterogeneous machine data. As I mentioned before, we don't really care about what the data format is. We don't need to shoehorn things into a schema. We don't have to say it must fit in this column and it must be of this particular data type or whatever. Our schema adapts on the fly. It's completely late binding. You can stream in events directly from your application code. You might not want to send it to a log file. You might just you want to reduce the moving parts in your application and just stream your events in as they occur. As I mentioned before, you might have some binary data floating around that you want to kind of decode and push into Splunk as well. It allows you to centralize all your data across your environment. I'm sure if there are any ops guys in your audience, you've felt the pain of having to troubleshoot an issue and having to go to this machine and this machine and this machine and this machine and get logs off this machine and kind of manually kind of stitch them together. Well, with Splunk's forwarding technology, all of your data across your environment can be centralized into one single place to go. Splunk scales out pretty much as far as you really need to go, more or less infinitely horizontally. Its architecture allows you to scale out your data collecting tier as your data requirements grow. We're talking into the hundreds of terabytes a day if need be. And you can also scale out your searching tier as the number of concurrent users using your system grow and increase over time. Internally, Splunk uses an implementation of the MapReduce algorithmic approach to enable this architecture, and I'll dig into that a little bit more later on. This is very important, being able to protect your data and define data aging and retention policies as well. And this is all very easy within Splunk. We've got very fine-grained permission controls. So obviously you can control your authentication to the overall system, but right down to a very granular data level, you can protect exactly who can see what type of data is going into your centralized environment, which is pretty important when people are running Splunk on a shared infrastructure. Data aging and data retention controls are also very important. You might want to keep data only for a small snapshot of time and then discard it. You might want to keep data longer for more longer-term analytics, or you might have some compliance or regulatory requirements. All different types of data are going to have different retention policies, and it's very easy to configure and control this within Splunk as well. I'll just mention a little bit about Splunk and Hadoop and where these two technologies kind of fit together, because I do get asked this question quite a lot. They're entirely complementary technologies. I build big data apps with Splunk, but I also code Hadoop jobs because I like coding Hadoop jobs. But each different technology is going to have its different place and different time to use it. So as I mentioned before, Splunk is an implementation of the MapReduce algorithmic approach, for lack of a better term. It is not Apache Hadoop MapReduce, the product, which is an important differentiator to make. Splunk is pretty much Splunk is not agnostic of its underlying data source. With Apache Hadoop MapReduce, you can pull in data from any different source. Splunk is pretty much tied to its proprietary storage mechanism on disk, which are these things called index files, which are essentially compressed flat files on disk. Splunk is optimized for real-time as well. Hadoop is batch-orientated big data analytics. Splunk can give you your visibility over your big data in real time, which is a very, very cool feature, and I'll show you some of this later on with a live demo. Splunk is more optimized towards kind of time series based analysis, and Splunk is a completely end-to-end integrated big data solution. Out of the box, you get your data collection, your searching capabilities, and your visualization all in one easy-to-use solution out of the box. And as I mentioned before, a very fine-grained protection of access and controls into your data, and data retention and aging policies. We basically make it very easy for you to create jobs, to use the analog in the Apache Hadoop MapReduce world. You've actually got to go and code your job for your map, combine, and reduce stage. We make that a lot easier in Splunk via our custom Splunk search language. But, why not get the best of both worlds, There are things that Hadoop is going to be good at and there's things that Splunk's going to be good at. So we have various products to enable interaction between the two products there. We have a product called Splunk Hadoop Connect, which enables two-way data flow between Hadoop systems and Splunk systems. So you might perform some analytics in Splunk and output those results into Hadoop, and vice versa. You might do some batch type analytics in Hadoop and output that into Splunk. And we can archive stuff off the HDFS and Amazon S3 and things like that. So Splunk out of the box, if you just go and download it, it's kind of like a monolithic install. But when you're talking about an enterprise-wide deployment, you can actually split Splunk out to serve various different concerns. And this is kind of the premise of how it's going to be able to scale to deal with lots of users submitting jobs and lots of data coming in every day. So we have a thing called a Splunk search head, which is where your users are going to come in and execute your searches from. We have our Splunk indexes, where the data collection component is going to occur. We have a Splunk deployment server for managing your environment. Some customers out there are going to have thousands and thousands of Splunk instances running throughout their infrastructure. So we have this thing called the deployment server. The alternatives to this are using Puppet or Chef. If you're in infrastructure ops guys, you know what those are. And we have these things called forwarders in the Splunk world. So these are basically very lightweight collectors which we can send out there to collect the various sources of machine data that we want to get into Splunk. And we can deploy literally tens of thousands of these if we need to. So just expanding on that concept of the forwarding and getting the data in a little bit more, there are basically two main ways you're going to get data in. You might use a forwarder, so you might deploy a forwarder to a remote system which can sit there and monitor log files and push these into Splunk. Or you might not want to use a forwarder at all, in which case you can just stream data directly into Splunk using UDP or raw TCP or HTTP REST, or you might have some custom scripted input which polls a management interface or does JMX polling or does SNMP polling. As I said before, Splunk is completely extensible with respect to getting data in. I'm yet to encounter a scenario where I haven't been able to get data in with the out-of-the-box functionality or just creating something customized. So you've got the options and the flexibility to suit your particular requirements here. You can use a forwarder or you cannot use a forwarder. Up to you. So our universal forwarder there, allows us to, pull data in from many different sources across the enterprise. It's designed to be very lightweight, minimally invasive, and have a low resource footprint on any system that you deploy it to. Many customers have actually embraced Splunk, tend to include the Splunk Universal Forwarder in the base OS images. So basically when they fire up a new instance, whether it's a client machine or a server machine, the Splunk Universal Forwarder is already part of that kind of core image. So as I mentioned before, Splunk will scale out basically infinitely horizontally as you require it to. You might be indexing 500 megabytes of data a day. Then you might move up to 10 gigabytes a day, then 100 gigabytes a day, then a terabyte, then 100 terabytes, and maybe one day a petabyte or 10 or whatever, So as your data collecting position increases, you can just keep on scaling out horizontally at the indexing tier as you require it. And our forwarders are really cool. They've got heaps of nice functionality built into them, like auto load balancing and compression and security and failover capabilities. So if some of the indexes go down, the forwarder will know to load balance over to another available indexer. And in-memory buffering, so we don't lose any data in the case of failures. You might have your data distributed across multiple data centers throughout the world, multiple topologies and whatnot. So what we can do is through a single search head or a cluster of search heads, aggregate all this data from around the world. I have a data center in France, a data center in the UK, one in America, one in China, all with their own Splunk indexes there collecting data. But you can have a centralized Splunk search head which can provide a single pane of glass view into all of that data. So we can route data in real time into our Splunk indexes, and then we can forward it off into other systems, which is quite important as well. You might want to forward it off into a custom SIEM solution, although Splunk can do SIEM itself as well. Or you might want to fire an alert that gets sent off to a service desk or some sort of trouble ticket system or Jira or something like that. Splunk is built in high availability and disaster recovery functionality. I will just make a quick note that there are changes to this architecture coming in our forthcoming release of Splunk 5.0. We're currently up to Splunk version 4.3.4. So this diagram is related to the currently released version that you guys can go out and get there. But this will change a little bit in 5.0. Just a disclaimer. So basically what we have here is we've got our forwarders down here, which are collecting data out in some remote system. So this guy here is set up for auto load balancing. So we've got an indexer cluster here. So let's say it's monitoring a log file. It's going to, and a log event comes in, it's going to send one of them to this guy, then the next one over to there, then the next one over to there, the next one over to there, in a round robin style scenario. It's also got auto load balancing algorithms where the actual algorithm of where it sends the data to will change over time. But the cool thing is if this indexer here goes down, then a Splunk forwarder is intelligent enough to know that this guy's gone down. It will start sending it over to this guy over here. If you want full disaster recovery capabilities, we can actually tell our indexers here to when they receive data, they can actually make a copy of it and clone it over to a DR site over here. So if any of these guys go down, your users coming in here through your Splunk search head are not going to miss any data or lose any data that might be critical to their operations. Integrating external data is very important. So obviously you're indexing all your machine data, but sometimes the machine data might be a little bit meaningless. You want to enrich it with other information. So you can see in this example here, Splunk has gone and indexed some sort of log event here, and it's got an IP address in there, which is kind of cool. But we can actually enrich that information by doing a lookup on that IP address to get some more, higher level geo information. So we can actually do a lookup on that IP address there and realize that, oh, actually that IP address comes from Atlanta, which might be more meaningful to, a level 1 support person. A level 3 technical guy might love IP addresses, but not everybody needs these in a kind of support and operational visibility type scenario. Likewise, you can see here we've got an account number. So we're able to maybe do a lookup of this account number and resolve it to the fact that this account number is related to this particular marketing area over here. And when you're actually doing these data enrichment lookups within Splunk, that data is not actually getting indexed. It's all dynamic at search time. So you get your core kind of machine data coming in, and whatever you have in there, you can just enrich with these lookups. You may have like some sort of like a Windows event code, which is quite a common one, and you can then do a resolution of that Windows event code to what that actually event code means. Log on event, log off event, or AD went down or whatever. Splunk has very fine-grained role-based permissions and controls over all of its data. Splunk's got its own internal authentication mechanisms, but obviously if you've got an AD-based system or some sort of LDAP authentication system, Splunk can certainly integrate with those, which is quite important. When you move on to using the enterprise version of Splunk, obviously you've got to go and buy a license. But we have a centralized license management policy, which makes it a lot easier to control how and where you license and dividing your licenses up between various departments within your organization. You might have a large organization with a 100 gigabyte license, and you might want to divvy it up, say that this department's only allowed to use 10 gigabytes a day, this department can use 50 gigabytes a day, and this other department can use 30 gigabytes a day, and some other department can use 20 gigabytes a day. Splunk Enterprise is licensed on the amount of data that you index per day. So that's the licensing model there. Real-time search is one of the cool features of Splunk and kind of one of its differentiators over some other big data technologies out there in the market. So what we actually do with Splunk as machine data comes in, we persist everything to these specific index files on disk, which are proprietary to Splunk, but we also keep all the data in this real-time buffer, which allows us to do searches and correlations over all of our data for a particular window of time, and also then augment this to be able to do real-time alerting, which is really cool. We can certainly do kind of reactive alerting over whatever period of time you want, but ops guys I think it's quite important that they know of things as soon as they happen. So with all the machine data streaming into Splunk coming through our real-time buffers, we can schedule these alert searches against whatever's in our real-time pipeline. So as I talked about already a little bit, Splunk doesn't require a schema on its data like many solutions out there do. That they'll kind of shoehorn you into saying that your data must fit into this particular model. We don't need to ETL stuff up front. You can certainly get your logs and your various events into a best practice semantic format, which is quite important if you're developing stuff. But often you're not in control of the various sources of machine data that you're going to be wanting to ingest. So a lot of the stuff's just going to come in completely random. It's you might have a semi-structured stuff in a JSON or XML format, or you just might have some random logs that some developer who hasn't really thought about it too much has just spewed out to a log file. So Splunk doesn't try and schemarize this stuff up front. What we do, however, is we dynamically extract fields at search time as you require visibility into that data. We have our own Splunk search language. It's called the search processing language. It's kind of, think of it like maybe Pig or Sawzell, or Sawzell from the Google world and Pig from the Hadoop world, but it's a lot higher level and a lot more user friendly, and it's built around the kind of Unix pipeline style of doing commands for its kind of reductive capabilities. And at the very simplest level, when you're doing a search in Splunk, it's kind of like doing a search in Google. You've got Google for the web data, and you go in there and you want to type in, is Lance Armstrong a drug cheat? And it might give you an answer. Kind of same thing in Splunk. You go and type in, error or exception or fatal or something. It's going to trawl through all the data that you've ingested and go and find all this information for you at a very simple level. Then you can expand that with our custom search commands and get some real detailed operational visibility and statistics and correlations across all of your machine data. You might have 10 or 15 different systems involved in a transaction. You can pull all this data in and correlate and stitch all this stuff together in real time in Splunk to give you an end-to-end view of that transaction in one single place. So how does Splunk kind of perform this black voodoo magic under the hood where we don't need a schema? Well, there's a lot of smarts internally kind of at an engineering level, but it's basically looking for patterns and trying to detect things and intelligently extract things, like timestamps, for example. Splunk is time series based. It's doing your analytics over periods and windows of time. So one of the first things it's going to do when data comes in is it's going to try and look for a timestamp in a known pattern. If you have some bizarre kind of format, then obviously you can train Splunk and tell it and teach it what that particular format of that pattern is going to be and look like. And Splunk can automatically extract fields if they're in a particular format. They might be in a nice delimited format, like you might have some log files come in with key value pairs or delimited by equal signs or colons or whatnot. And Splunk can kind of try and look for these types of patterns and infer that what a particular field is. And then you can then take those fields out of your machine data and use those for further analytics downstream for creating various reports and dashboards and tables and alerts. We can then go and basically enrich our various log events that are coming in by adding more what are called knowledge objects to them, so we can do tagging on particular types of events, and we can say that particular types of events are of a particular event type. So we might create a Splunk search that looks for exception or fatal or error, and just any events that have those words in them, and define them as being the bad event type. So we can just go and search for all bad things, So it's just all about knowledge enrichment to make the search process a lot better. And this is kind of, how Splunk's late binding schema approach works. And we can change all this stuff on the fly. So one day you might be extracting certain fields and applying certain knowledge objects to them. The next day, off the very same data, you might have changed that and you might be extracting entirely different fields from those log events. And I'll show you an example of doing some of this sort of dynamic extraction later on with a live demo. So that's just like a basic overview of kind of the core features of Splunk that you might be interested in getting to grips with. There's a lot more with the product, so you obviously download it, you can use it for free and just start digging and playing around with it. And feel free to ask us any questions whenever you need to. So while you're all here, I guess most of you are developers if you're at this conference. Just put your hands up if you code, if you're a Java coder or a Scala coder or a Groovy coder, or so that's like all of you, all right? Good. My hand too. So the Splunk product is basically built around some very simple components. You have basically the core engine of Splunk, and the core engine of Splunk is what is responsible for collecting all the data, allowing you to search over all of that data. Out of the box, you get Splunk UI. It's a web-based UI, which is really cool, and it can get you up and running and searching and visualizing over your data very quickly and very rapidly. But every single piece of functionality that is available in Splunk is exposed via a REST API. And the web UI out of the box is using the REST API for all of its functionality and communications to the core Splunk engine. So what this allows us to do is be able to develop on top of Splunk as a big data platform. We can use the Splunk platform to ingest all these various sources of machine data over here, and we can make use of the Splunk search language to derive some visibility and insights into all of this machine data, and we can build our own custom apps on top of this via the REST API. And there are three kind of main use cases in which developers are probably going to be interested in developing on top of Splunk as a platform. You're going to be interested in using it throughout your dev, test, and qual cycles before your code gets into production. You might already have some existing management and monitoring infrastructure, but you want to take advantage of Splunk, so you want to integrate some of the visibility and results you can get from Splunk into your existing systems. Or you might want to build a big data application from scratch and consider using Splunk as your platform for your big data solution. Just a quick plug here, dev.splunk.com is where all of the dev platform stuff is. We're on Twitter, and we also have developer licenses if you're interested in getting hold of one of those. So we actually download Splunk, and you can use it for free. And you get to index 500 meg a day. But if you're a developer and you want a little bit more flexibility with the time of your license and the amount of data you can use, you can just contact us via the site over here, and we can look into getting you a developer license where you can index a lot more data a day. So I mentioned there's kind of three main approaches that we're thinking about with respect to developers and how we want you guys to be thinking about using Splunk as a big data platform. And these are all things I've actually used before I was actually a customer. Before I was a customer of Splunk, I was running a development team, and we were using Splunk, to enable, test, dev, test, and qual, basically to get the insights from Splunk to make our software better before it got into production. So, how is Splunk actually going to help you as a developer through dev, test, and qual? Well, you don't need to define any schemas or database structures up front for storing all your machine data throughout your cycles. We can just keep it loose, and throughout dev and test, obviously things are changing quite a lot, which is quite important. This is a very important one here. I'm sure we've all felt this pain point here where we're trying to debug an issue, but we don't have access to the particular systems. So you've got to call a various bunch of departments, and maybe an hour later you have access to the logs, which is kind of a waste of your time because you needed them instantly. So using Splunk, you can have all of your logs and machine data and whatever being pushed and aggregated centrally. So you have access to all of the stuff, basically in real time at your fingertips as a developer. Again, with the role-based permissions, we can make sure that only the right people can see what they're allowed to see. So your managers won't be able to come in and see all the bugs in your code, basically, if you don't allow them too. Yeah, so basically Splunk is going to let you dig down and search and find more issues more rapidly and more quickly. And this is a very cool one down here, being able to integrate Splunk search results into your testing assertions. I've used a load testing harness before called Grinder, which is like a Java and Python based load testing harness. And you can fire off a load test and let it run for a week. And at the end of the week, I typically find people with load tests see that, well, I sent 1 million messages, I got 1 million responses, the system didn't fall over, things kind of look okay, all right, let's push this into production. Well, actually, throughout the course of that week, you could have been Splunking the system that you were load testing to get fine-grained analysis over, how is my JVM heap going, how are my thread pools, how is my garbage collection throughout the course of that test. And at the end of the test, you can execute a Splunk search from your testing harness and use the results of that Splunk search to form the basis of your testing assertions. So basically getting more deeper and more thorough assertions to make sure your code really is thoroughly load tested and production ready. You can integrate Splunk into your IT environment. So as I mentioned before, we have a very thorough REST API which covers all of the functionality in the core Splunk engine over here. So you can code at the REST layer if you want, and many people do this, and you get a lot of control because you're kind of limboing a little bit lower there. But we want to make it a lot easier for developers to be able to use our REST API. So we have software development kits available in many different languages, and these basically just sit on top of the REST API and make it a lot easier for you to use it. Via, what have I got? There we go. So our Splunk REST API, as I mentioned, exposes methods for every feature in the product. Via this, you can input data into Splunk, you can manage Splunk, or you can run searches against Splunk using our search processing language. Our API is totally RESTful, get, post, delete, HTTP methods. Our responses are Atom XML feeds. We've got pure JSON coverage coming in 5.0. When you execute a Splunk search and you get those Splunk search results back, you can specify what format you want those search results back in. So you can have CSV, JSON, XML, or just plain raw. So raw is the actual format that the raw events actually got indexed to Splunk in the first place. So a developer platform SDKs will sit on top of the REST API, and the whole idea is we're just basically trying to make it as easy as possible for developers to build apps, to build big data apps on top of the Splunk platform, really lowering the barrier of entry as much as possible. We've got many different language offerings out there. Our 3 most recently released ones are JavaScript, Java, and Python. They would be our most mature ones. PHP recently got released at Splunk Conf last month. And we have a couple up on GitHub which are in private repo, which are fully functional and people are using those. So if you ever wanted access to any of those, again, just get in touch with us and we can hook you up with access to those GitHub accounts. Again, all of Splunk functionality is available via our SDKs because they sit on top of our REST API. And typically you're going to be getting data into Splunk, executing searches against Splunk, managing Splunk, and if you're using JavaScript, you might be creating a customized user interface for things that you can't maybe do through the Splunk web UI out of the box. And the third kind of use case is you're just building a custom big data application on its own with Splunk, using the Splunk platform as your big data engine for collecting, correlating, and searching over all of your data. So again, with Splunk, there's no need to write MapReduce jobs to be able to have MapReduce functionality. We basically create our MapReduce jobs under the hood via our Splunk search language for you, which really exposes this whole big data paradigm to a wide audience. If you're using our Splunk web UI, you might have, your service delivery managers or upper management or even executives, using the Splunk web UI, and they don't know, but they're actually creating MapReduce jobs under the hood. without the need to actually go and write all that code, obviously. Again, if you're building a custom big data app on top of Splunk, you have that real-time functionality, which is very important across all of the heterogeneous sources of machine data that you're indexing. Our late binding schema basically gives you more agility and flexibility into how you want to see and use your data. It can change on demand as you require it. Splunk's an integrated platform for collecting your data. It can scale out as your data requirements grow and your searching requirements grow and your user base grows. And our SDKs cover most of our functionality. So I think there's some pretty good cases there for if you're thinking about as a developer and you have a big data problem and you need to build a big data application. These are some of the key things you might want to think about when you're considering using Splunk to do that. Okay, I mentioned before, you might want to create your own custom user interface. So the Splunk Web UI out of the box is pretty cool. You get a lot of functionality and you get some really cool charting controls and timeline controls, and I'll show you some of these later on as well. But you might want to extend it. You might be the world's greatest JavaScript D3 whiz, right? And you want to do some really cool visualizations. So we can actually use our JavaScript SDK. And if we want, we can integrate with any third-party charting library, Google Charts or D3, to create whatever kind of custom visualizations that we're interested in. So this is just a screenshot from an example of the various things from the D3 library. But you could build your own custom visualizations using things like this, which actually use the Splunk Big Data Platform in the background to collect and crunch all of your data and execute searches against that data, real-time searches, and use these to do these types of things to do real-time visualizations in your browser. Splunk is fully HTML5 compliant as well, so for you iOS guys out there, then that's fully supported. So I've got a real-time Twitter visualization demo. We've actually had some of this running out on the screen over there in our booth, but I'll just dig a little bit into the architecture, how that works, and then I'll show you it running up live here. So basically, what we have is that we have a Splunk indexer running over in San Francisco right now, and we have a Twitter Firehose feed coming into that, and we're using our JavaScript SDK on a Node.js web server, which I actually have running locally in my laptop here, to execute a real-time search against Splunk to pull out certain Twitter results that I'm interested in real time. There's a lot of data coming in here, a massive amount of data, but I don't want all of it. I just want Splunk to be able to crunch it down and give me what I want in real time. So I've got a web server running over here. Our JavaScript SDK has a server-side component, which will run on Node.js, and obviously it has a client-side component, which will just run on the browser. So in this example, I'm using the Splunk JavaScript SDK on the server side. And so this is executing a Splunk real-time search to there, and then we're using WebSockets to stream this down to the browser over here. And we've got a nice little custom visualization down in the browser using a few different D3 charts. Real-time Twitter demo time. So just 1 second here. I'm just going to start up my Node.js web server. All right, so that's started up. Let's go over to Chrome over here. All right, so that's working, thank goodness. Everything can go wrong with live demos. You just need one thing to go right. So what we actually have here is that this is a real-time stream of all the hashtags which are currently in tweets across North America right now. So these are 3 different D3 charts over here. We've basically got a geo heat map. The darker the color, the more prolific the tweet is. Obviously Texans like tweeting for whatever reason. We've got a nice little kind of pinwheel chart down here, and we have a word cloud. And this is all entirely interactive as well. So if I go and hover over Texas, you'll see that the pinwheel changes to show what are the most popular tweets currently happening. And this is in real time right now, okay? As it's streaming down through Twitter, into Splunk, down to our Node.js web server, and into the browser.
Real fast. So is this something custom that you've written, or does Splunk have viz tools that would
Splunk, yeah, so Splunk has its own visualization tools out of the box, but it doesn't have this one here. So this is a custom UI that we've created. Yeah. So actually these charting controls are available via the D3 project. Likewise, Google Charts is pretty cool, so you could do some of that stuff and integrate those in. So we've actually created this logic in the browser ourselves, but on the server side, that's all using the Splunk JavaScript SDK, which you can download and use that. So again, if I hover over a particular state, the context of the pinwheel and the word clouds are going to change based on where I'm moving my mouse over here. So I don't know what California are tweeting about at the moment, like various different things. Maybe whatever's topical at the moment. Likewise, I can go into word cloud and I can actually just hover over a particular thing in the word cloud. So let's just hover over jobs. So who's tweeting about jobs at the moment? Lots of people over here on the East Coast and Florida are tweeting about jobs, which is kind of cool. So I won't spend too much time on that, but that's just an example of how we can augment the Splunk UI to take it basically as developers to whatever place you want to potentially take it. Just out of interest, I was watching a presidential debate last night because as a New Zealander who can't vote, I'm so interested in that stuff. But it had a good vibe. At one point I thought Obama was actually going to bite off Mitt Romney's ear, a la Mike Tyson. I could sense that frustration. But anyway, I ran this Twitter demo last night just to figure what was going on. And you can see this was about midway through the debate, and I guess people using the Romney hashtag were outpacing people using the Obama hashtag and various other things related to the debate. And again, Texans like to tweet and Californians. Maybe that's the population of those states for whatever reason. So I mentioned the various SDKs that we have out here, the various language SDKs, JavaScript, Java, Python, Ruby, PHP, C#. But this is a kind of Java, JVM, Groovy, Scala crowd. So I'm going to focus on the Java SDK, and we'll move into some code examples here. So again, the Java SDK is completely open source. You can go up to GitHub and download it. We've got out-of-the-box project-level support for Eclipse or IntelliJ, but you can really use any IDE that you're interested in using, via Emacs, up to you. It's got a base requisite of JRE 6+. Currently supports Ant. There's Maven support in the works at the moment. And if there are any Gradle guys out there who would like Gradle support, by all means, just get in touch with us. We're very receptive to the community's needs and requirements, and we'll build it into our work pipeline. There are loads and loads of code examples up on dev.splunk.com, and when you download the SDK, there's examples folders and obviously unit tests. I don't really like reading docs. I'm a coder. I just like looking at code. So there's lots of that to be able to get you up to speed with most of the core use cases that you're going to be using the Java SDK for. On my own personal guest site, I've also got loads and loads of examples as well. Don't worry about scribbling this information down. If you've got the USB drive here, this entire presentation's on the USB drive that's in the top of the pen that you got as your Rego pack. And again, the Java SDK has complete and comprehensive coverage of the REST API. The class model in the Java SDK is actually very, very simple. We want it to be that way, and we want it to be intuitive for developers to use. We don't want to burden you with complexity. So the main thing you'll be dealing with in the Java SDK is this thing called the service class. It's kind of like a wrapper class that's going to facilitate all your access to the various Splunk endpoints. And then we use this collection structure over here, which is basically like it's an abstraction of a container for dealing with the various entities that you're going to be managing within Splunk. So within Splunk, you might have saved searches, so a collection of saved searches, or a collection of apps, or a collection of users, or a collection of tags, or a collection of event types, or a collection of TCP inputs, or a collection of UDP inputs. So this container structure is a mechanism by which you kind of add and retrieve the various individual entities. Then once you actually got handled to an individual entity, like a user object or an app object or a saved search object, you can then work on the individual properties of those particular objects and then persist those back to Splunk for management purposes. So the key things you're probably going to want to do with the Java SDK, and which I'll show some code on now, are obviously connecting to the core Splunk platform and authenticating, managing Splunk, managing all the various things like users and applications and saved searches and the tags and event types, getting data into Splunk, which is quite important, and obviously getting data out of Splunk and searching and using our Splunk search language via the SDK. There's a lot of code I could potentially show here, and I've only got a certain amount of time to get through all of this. So I'm just going to show you the main entry point level stuff, but we can certainly dig deeper on any of the particular examples offline if you guys are interested in doing that as well. So very simply, the first thing you're going to really be doing with the Java SDK is actually connecting to Splunk and authenticating, and it's actually very simple. We're just taking a hash map of all the various connection or authentication parameters. Some of these are defaulted under the hood. You don't have to specify all of these, but I'm just showing this for clarity. You can also specify a .splunkRC file that might reside in your home folder and use that as your means of getting the connection properties loaded into Splunk. So as I mentioned before, the service object is going to be your main entry point into the functionality in Splunk. So all we're doing here is we've got a nice little static method and we're connecting to Splunk with our various connection arguments over here. So we've got a host, a username, whatever password we're connecting to, our port and our scheme. Everything's HTTPS, so it's completely secure. This is just a very simple example here of managing Splunk. Obviously, you can manage any aspect of Splunk. So in this example here, I've connected to Splunk and I've got a handle to my service over here, which is this example over here. I've got a handle to my service, and all I'm doing here is I'm hitting a particular endpoint over in Splunk to get some simple server information dumped out, and I'm just printing this out to the console. Very simple interface, and most of the REST API is abstracted in the Java SDK in this sort of a manner over here. Inputting events. So we can input events via HTTP REST or raw TCP or raw UDP or syslog UDP. So when we're submitting stuff in via HTTP REST or TCP, we could do one-shot stuff where you basically open a socket, send it in, close the socket. Likewise with TCP, open a socket, send some events in, close the socket. But if you're sending high volumes of data in, that's obviously not very performant. So we can stream stuff in and basically keep that pipe open and send millions and millions of events in per minute if you have to. So in this particular example here, I've gone and connected to Splunk. I've got my service handle. I've got this thing called a receiver object, which kind of the naming here correlates to the fact that we've got a receiver's endpoint in Splunk. I'm creating a few arguments here. Basically what I'm doing here is I'm tagging my log event with some metadata that Splunk can use. So the source is kind of where it's coming from. The source type is what is this data? And then I'm just simply going log, and this is just going to stream this over HTTP REST to Splunk. But it actually uses HTTP REST to initiate the opening of the streaming connection, and then you basically have an output stream handle after that, in which you can then internally use it. Splunk uses the Java SDK uses that to stream the information into Splunk. Searching is, aside from getting data into Splunk, searching is probably the main thing you're going to do. When you actually download and use Splunk out of the box and you're using the Splunk UI, Splunk web-based UI, you're basically just typing in your search commands into a text field and clicking go. So under the hood, you're not really aware of the various types of searching you can perform. But when you're programming this stuff yourself and you're doing searching via the REST API, there are many, many different types of searches that you can use to facilitate whatever you're trying to accomplish. So a search query in Splunk is just a set of commands and functions that you can use to get stuff out of Splunk. So in this particular example here, I'm just going and looking in the Spring index. An index is like just a bucket where I've configured Splunk to put all the Spring-related events I'm sending in. And then within that index, I'm just looking for all events that have the word error or exception in them. Just very simple syntax. And then our search commands use a piping, Unix-style functionality. So you're basically taking the outputs of one section and you're redirecting them as the input to another search command. And this particular search command in Splunk is just going to return the first 10 results it finds in the Spring index where my log events have the word error or exception in them. So we can type our searches in line, but it's quite nice to capture knowledge and retain and reuse that over time. So in Splunk we can actually save these searches, and these saved searches are actually objects in Splunk that we can manage via REST API as well. I've worked in some organizations where people have thousands and thousands and thousands of saved searches, which is kind of cool because when that security guy leaves, he's not taking all the knowledge about how he diagnosed security incidents with them. He's retained and captured that knowledge in Splunk via the saved searches. So a search job, again, is just an instance of a search operation. You can think of it as being analogous to a MapReduce job. When you submit a search, when the Splunk search language submits a search job under the hood, you get a search ID handle, which then you can use to query the status of that job as you require it. Job results get saved on the Splunk search, on the Splunk indexer for a certain period of time. So in the case of, a network failure, as long as you've got a handle to that particular job ID, when the network connectivity is restored, you can just reconnect back to the Splunk indexer and poll the status of that job and get the results back. You're not going to lose any information there. So there are many different types of search modes that you can use under the hood via the Java SDK. This is the most common one, very well named, the normal mode. But basically you submit a job and it's completely non-blocking, and you can go away in your code and do something else. You get a handle to the job ID, so you can come back and poll the status of that job and get the results when they're ready for you. Then we've got real-time mode, which is basically the same as normal mode, except that you pass these special time modifiers through in your search request to tell Splunk that you want a real-time window kept open. So basically it's keeping a socket stream open and streaming real-time results in a particular sliding real-time window back to you. This is a normal mode where you might just have said, please execute the search over the last 2 weeks only, a fixed period in time. But the real-time search will keep a sliding window open and just stream those results down. And that's exactly what that Twitter demo I was doing was before. That was a real-time search. It was just keeping a real-time search window open. And as new data came into Splunk, it was picking up on that and feeding it down to my browser. We've also got, so these, the normal and real-time, these are obviously asynchronous, non-blocking searches. But we've also got blocking searches, which you might want to use from time to time. You might only have a very quick search that you want to execute. So what these will actually do is in your code, you're going to execute the search, and that bit of the code is just going to block there until the search is completed and the results are returned back to you. Then we also have this thing which is technically in Splunk spec not a search. It's called an export. But if you ever wanted to do bulk dumps of all your data out of Splunk, then this is the mechanism you'd use to get bulk dumps of data out of Splunk, which you might want to use for exporting off to another system or something. So here's a little bit of code. So here's some example of just some blocking searches to start with. So what we're doing up here is, again, I'm connecting and authenticating to Splunk and getting handles to my service instance over here. I'm constructing a Splunk search query here. So in this example, I'm just searching for anything with the word error or exception in it and returning 10 results back. I've specified some time modifiers in here. So this time modifier is saying I'm interested in all events that have basically occurred in the last day, snapped to the day, up until now. And then I'm going to go and execute, in this case, an export. And this is actually going to block here until the results come back. Likewise here, I've got this thing which is, I guess, very similar to an export, but has just various subtleties over how much data you can actually return back. But again, very similar again, it's just going to perform a blocking search down here. So you typically use this if you wanted to get all data back out of Splunk, and you typically use this method here if you're just interested in a particular slice of time or a particular fixed set of events. But this is the one I primarily use most of the time because we like non-blocking and asynchronous and all that good stuff. So again, we're connecting to Splunk and authenticating, and this time I'm actually telling Splunk what output format I want my results to come back to me in. So we have the option of specifying XML, JSON, or CSV. So I've just said, please return my results back to me in CSV. In the Splunk Java SDK, we actually have decoders. We used OpenCSV for decoding our CSV results. We use JSON for decoding JSON results. And we use the native XML streaming in the JDK for decoding our XML-based results. And this is what this method actually down here, process input stream. There's an example of this up on GitHub, which shows usages of these various decoders based on whatever output format you're interested in. So again, I'm going up here now, and I'm actually submitting my search job into Splunk. And again, just a very trivial search here. I'm just looking for all errors or fatals in the Spring Index and returning the first 10. But the cool thing is this returns immediately. Okay, so you can go off in your code and do something else. And we've got a handle to the job object over here. And this is basically an abstraction over the job ID. So you can go off in your code, do something else, come back, and very trivial loop here. I'm just polling. I'm waiting for the job to be done. I'm asking Splunk, is the job done, is the job done, is the job done? And there's various other methods that you can use to poll the status of the job. And then basically once the job is done, it's going to obviously exit from this loop. Then it's going to come in here, and I'm then telling the job, okay, once the job's done, please go and grab me my results now based on whatever output mode I'm interested in. And it's going to return those results back down in CSV, and I can process those. A real-time search, as I mentioned before, is basically exactly the same as this. The only difference is the real-time search, I'm just specifying these RT, these real-time time modifiers. And that's all I have to do to turn a normal search into a real-time search. So what these time modifiers are actually doing in Splunk is they're keeping open a 5-minute sliding window. And in Splunk, I've just got the sliding window going across, looking for any events that are coming in within this window and stream them back down to me. So based on whatever the search you're executing is, this is just a trivial example, but you might have a really complicated, correlation going on, correlating across, 10 different sources coming in and refining those and reducing those down to some results and getting that feedback to you in real time, which is really, really powerful. So, I'm a Java programmer, but I'm also a Scala programmer, and I'm a Groovy programmer, and I'm just a general all-around kind of JVM fanboy, to tell you the truth. I was at a conference a little over a year ago, and Jim Gosling was presenting at it, and he basically said he does not care about the J in JVM anymore. It's kind of, obviously J means Java, but it's really not about that. It's a platform for multiple languages to cohabitate, and they all boil down and work at the bytecode level eventually. So I think that's really cool. So given the fact that they're all running on the JVM, we don't need to go and create, separate JDKs really for all these different JVM languages. We can just interoperate with the Java SDK. Yeah, certainly we could go and create a Scala SDK and a Groovy SDK if we could, but we can just hook into the Java SDK and get all that functionality if you want to program in those languages. So here's just a simple little bit of Groovy code. If there are any Groovy gurus in there, don't hassle me. It's not my first language. But basically, this is just a simple example in here of, again, I'm passing my connection parameters. I've got a service object here, and then I'm hitting an endpoint in Splunk just to get some basic server information over here. And then I'm printing it out, again, using the Java SDK via Groovy. Similarly, with Scala, I can do exactly the same thing over here. Again, I'm setting up my connection parameters to connect to Splunk. I'm getting a handle to my service. I actually think the code in Scala looks better than the code in Java for the Java SDK, ironically. It's more succinct and clearer. And then I'm getting a handle to the server information endpoint, getting the results and just printing it out again. So if you are a Groovy or a Scala programmer or any other JVM languages, just think about using the Java SDK as well. Okay, now, so this is hot off the press. I just want to give a special thanks. I don't know if they're in the audience tonight. No. To Jared Lee, Mark Pollock, and Mark Fisher for basically creating this and driving this. And I just answered a few emails. But these guys were really busting out all the code, and we basically got this out in release just before the start of this conference. So we've been working on creating some custom Spring integration extensions for Splunk to make it easier for people building Spring-based solutions to integrate Splunk functionality into their applications. Is Mark Pollock here, by the way? We've talked on the phone, but I've never seen him in person, so I don't know what he looks like. All right. So for those of you, some of you may be very familiar with obviously Spring and Spring integration already. But if you don't know what it is, Spring integration is basically just an extension to core Spring. It's based on the enterprise integration patterns model. And it makes it easier for you to build data integration type solutions in a Spring context. Hot off the press, if you guys have read through your Regio pack, there is a Spring data book out there now. And at the literally at the 11th hour, Mark Pollock managed to get a couple of sections introduced into the book on these new Spring integration Splunk adapters. So you can actually go to the O'Reilly site and download this preview of this book for free. I downloaded it last night and it actually looks pretty cool. Above and beyond the Splunk stuff, there's heaps of other cool stuff in there about all the various other integration adapters for Hadoop and a whole bunch of other really cool technologies. So I think it's a great book. And it's free. Free's good, right? So the Spring integration Splunk adapters here. If you think of the Splunk Java SDK as making it easier for developers to use the underlying REST API, building on this, the Spring integration adapters make it easier for your Spring and your Java developers to declaratively build integration solutions that utilize the power of the Splunk platform. Again, it's just making it easier and simpler for you guys to make stuff. The Spring integration Splunk adapters are all up on GitHub, so you can go to this location and download them. There's a very simple README there which will give you all the information you require to get up and running. And we basically have two adapters created. We've got an inbound adapter, which allows you to execute Splunk searches and pull data out of Splunk. And we've got an outbound adapter, which allows you to get data into Splunk. So in a Splunk end-to-end, in a Spring end-to-end integration solution, you might have various different adapters. There's some JDBC adapters, a Redis adapter, a MongoDB adapter, a Twitter adapter, whatever, a simple file adapter. So you're able to pull data in from sources, maybe do some transformation and filtering inside of Spring, then forward this into Splunk. Conversely, with the inbound adapter, you can pull stuff out of Splunk, maybe perform some additional transforming and filtering in Spring, then forward it out to maybe another destination that utilizes another one of the Spring integration adapters, like maybe the JDBC adapter or maybe the MongoDB adapter or whatever. So there's just some simple diagrams about how these adapters are actually architected at an enterprise kind of patterns layer. So obviously the Splunk inbound adapter is what we use for executing Splunk searches, and all of the searching modes that I mentioned before on that slide are supported via this adapter. So you can do real-time stuff, blocking, non-blocking, and exporting of data via these adapters, via this adapter, sorry. And likewise, the outbound adapter for getting data into Splunk. So we can send data into Splunk via HTTP REST or raw TCP. It's got a very simple XML configuration. The Splunk descriptor is quite simple. We can specify our common Splunk settings for connecting to Splunk. So where our Splunk indexer lives and what port we're connecting to. This is always the default port for management. for the REST API in Splunk, but you can change this to whatever you want. And obviously our authentication information. And so when we're exporting data from Splunk using this inbound adapter, again, it's just a very simple XML grammar, and we can specify the main thing you're going to be interested in is specifying the Splunk search command over here. So again, this is just a very simple example. In this case, we're just looking for all errors and exceptions. And we can specify our time bounds that we're interested in pulling this data out of Splunk for. On the converse side, inputting events into Splunk, we can specify the metadata that we want to tag those events with that Splunk's going to use internally. What index, which is basically the particular file bucket where we want all the machine data to go and live in Splunk, and just where the particular feed came from and what the particular data was. And this ingest mode over here says this actually means submit this via HTTP REST into Splunk. All right, we've got half an hour left. So in this case, in this point in time, I am going to show you a demo. So what I have in this actual demo here is, again, I'm using Twitter, because, I don't know, Twitter's kind of seems hip and cool at the moment to use in demos. So what we have is we're using the Spring integration Twitter inbound adapter to pull some feeds in from Twitter, and these particular feeds are tweets from people that I am personally following. This data is coming into the Spring integration demo app we have. The Twitter feeds are being transformed into a best practice semantic logging format for Splunk, and then we're using the Splunk the Spring integration Splunk outbound adapter to send this data into Splunk, and then we can use the Splunk web UI to create some real-time visualizations over these Twitter feeds coming in. Just 1 minute. Alrighty. So I actually have a real Splunk instance running up on Amazon at the moment. So let me just log in here. Okay, so just before I actually fire up the demo app, the demo Spring integration app, I just have some Twitter data that I've been pulling in yesterday and a couple of days before, just to show you just a couple of basic things in Splunk before I actually wire up and create a real-time dashboard for you guys on the fly. This would basically, the whole goal of this is to show you how simple it is to create real-time visualizations using Splunk out of the box. So this is the Splunk UI, Splunk Web, which I've been barking on about, and when you download this and use this, you get all this stuff out of the box. So I've actually pre-saved just a couple of simple little searches here, and this very simple search here is basically I'm looking into the Spring index, which is just like a bucket where I've stored all of my Spring data, and I'm looking for all of the events in my Spring index which are of the particular source type Twitter feed. So there's a whole bunch of stuff down here that I've pulled in over the last just couple of days as I've been testing out things and playing around and mucking around. And the particular time modifier on this I'm specifying is just show me everything from all time. But I can actually just drill down on here and I can specify whatever various time bounds that I'm interested in for this data. We can then expand on this really simple little search here. And you might see that in these log events that are coming in, they've actually been reasonably well formatted. Nice key equals value pairs. And this is what the actual Spring integration demo app has done. We've got the raw feeds that have come in from Splunk using the Spring integration Twitter inbound adapter. And we've parsed those a little bit, and we've kind of reformatted them into this best practice semantic format, which is key equal value pairs, then pushed these into Splunk. Now the cool thing about this is that in this format, Splunk has basically gone and auto-extracted all these keys from these log events, which then allows me to take a raw input like this and simply extend it visually into a tabular fashion over here. So now we have our from users and the actual particular text that was a component of their tweet. I didn't need a schema for this, you know. This was all done on the fly, dynamically. We can then expand on that simple tabular output and do some more, you know, detailed statistical analysis. So I want to see which particular users are most active and which are sending the most tweets. So these are all guys that I follow over here. Conan O'Brien, I just think he's funny. I'm a golfer, so I follow Ian James Poulter. But then again, but also the point here is that we haven't needed a schema here to derive these fields and then go and apply the Splunk search language to do some sort of statistical analysis over this data. So what I've done up here is I've just gone and I'm doing a statistical count by the particular from user. And that particular from user was here. So that just got auto-extracted, which is quite nice. Now, we might... I'll just show you one more thing down here. Okay. Let's see if there are any hashtags in our feeds down here. All right, so that's kind of cool. So the hashtags weren't in a key value pair. The hashtag is just a raw value in my fields. If you look back here just in the raw events, some things are in a nice key equals value pair format, but you can see, there we go, there's a hashtag down there. That's just kind of floating text in a field. You know, that hasn't been sent into Splunk in a key value pair format. But I can just dynamically extract that out into a field, and this is, you know, this whole schema on the fly, late binding thing that I keep barking on about. So Splunk has been able to automatically extract things in a nice format, but I also want to be able to extract all these hashtags and use these for, you know, some of my charts and alerts and whatnot. So what I can do over here is that basically in line in the Splunk search language up here, I've basically done a dynamic extraction based on a simple regex pattern, which has gone through the text of my tweet message and looked for things that match this particular regex, and it's done a named extraction out into this field called hashtag, which then I can pipe through to the next step and use the top command to show me which are the top hashtags which have come through in this Twitter feed over all time. All time being since I started pumping stuff into this particular Splunk instance. So you can see, you know, people are tweeting about Splunk and obviously this conference, which is cool. Machine data and a whole bunch of other stuff over here. Likewise, I can do exactly the same thing over here, and I might be interested in just people who are doing retweets, and I might want to find who these guys are retweeting about. Again, the retweet user isn't coming in to Splunk in a nice key with a value pair format, but I can dynamically extract the retweet user from the raw Twitter message that's coming in. So over here, what I'm actually done, this is a pretty crude search, but I'm just looking for all of my messages that have RT in them, which hopefully this is just going to get me all the retweets. And then I'm looking through and applying a simple regex to try and pull out the retweet user from that. And I'm just giving myself a simple tabular view down here, which splits out the actual tweeter from the retweeter and just whatever the raw text was down here. So that's pretty cool. That's a very simple example of doing this kind of schema on the fly type stuff. So now we'll actually fire up. Yep, sorry.
Would you set up these extractions automatically so that every new tweet that comes in automatically gets specified with a hashtag tag?
Yeah, absolutely. So under the hood in Splunk, you can save your extractions. So you don't have to do it inline like this. You can save and persist this stuff and train Splunk so it learns over time. So next time it comes in, a hashtag or a retweet user or anything you're interested in will just be automatically auto-extracted for you, which is cool. So you as the admin, the Splunk admin might set up this sort of stuff, and your users don't have to worry about it. So let's just go down and have a look at a bit of code. So we've got this simple little Twitter app over here. It's just loading in a Spring context over here. I know it's misspelt, so don't point that out to me. So we're setting up our Spring settings over here for connecting to Splunk. This is my Spring instance. This is my Splunk instance that I have running up on Amazon. The port I'm going to connect to, and the authentication credentials that I want to use to connect to it. The actual Spring XML for this example is pretty simple. Again, I'm pulling in my common connection settings over here. Ignore that database stuff, but over here is my Twitter inbound channel adapter. So this is what is polling the various Twitter feeds that are coming down from the users on my particular account. The Twitter users that I follow on my particular account. And then I'm piping this through to the Splunk outbound adapter. So this step actually here is going to take the raw Twitter feeds that are coming in and just do a little bit of processing over them and format them into that kind of best practice semantic logging format of those key equals value pairs that I showed you before. And then spew these up into Splunk over HTTP REST. So I should be able to fire this off right now, and fingers crossed it should work. Okay, so it is working. So it's starting to poll things coming through down here. Various people that I'm following. So this will just keep on running and keep on polling what's coming in from Twitter. Now, if I actually go up to Splunk, so what I was showing you before was kind of a static time window, which I was searching over. It's very simple. I just want to turn this now into a real-time window. So I'll just give it a little bit of time to catch up. Hopefully my times have been synchronized, which is quite important. All right, so that's working. So this is now a real-time view of all the Twitter data that's coming in into that Spring integration app, being sent up to Splunk, and we're visualizing the stuff down here now in real time. You can see the little spinning wheel up here is kind of telling me it's doing a real-time search. So as people are tweeting, stuff is coming in. If I tweet from myself, you should actually see one of my tweets appear up there. So I'll do this from my cell phone right now. What should I tweet about? What a great crowd. What was the conference hashtag again? Was it Spring12GX, I think? Spring12GX. Here we go. What a great crowd. Spring12GX. All right, so I've gone and tweeted. Now hopefully my little Spring integration, oh, there we go, down the bottom. It's just popped up in real time. Damien Dallimore, there we go. So that's actually come in via the Spring integration adapt, Spring integration little demo running on Eclipse down there. It's fed this up here. Let's actually just do a search directly to check that was the actual real one I sent. I'm not just mocking this up and tricking all of you guys. So again, this is still in a real-time window. So there we go. What have we got down here? From Damien Dallimore, what a great crowd, Spring12GX. Okay. So this is a pretty trivial demo, but the whole idea is kind of getting you thinking about the various possibilities and how you can use kind of real-time data. I can now extrapolate these simple kind of tabular views over here. And I can very simply create a dashboard in Splunk. And again, this dashboard can be saved and reused by whoever, obviously wants to use it. So let's just take this simple search here. And first thing I'm going to do is turn it into a real-time search over a 5-minute window. All right, there we go. So it's streaming these real-time results down. And I want to visualize this using Splunk Web's inbuilt charting controls. So, you can do this and you can code this yourself by hand, but you can also very simply, do this via point and click. So this is just a very trivial example. I'm just going to create a dashboard panel. I'm going to save this particular real-time search. User tweets count real-time. I'm going to create a new dashboard. Spring presentation. Panel title, that'll do. How do I want to visualize this? I think the pie chart will do. We'll see how that goes. Okay, that's done. So I'm going to create a dashboard, and that dashboard has magically appeared up here, Spring presentation. So hopefully, if the live demo gods are on my side, we should see a real-time pie chart pop up pretty soon. There we go. Just like that. That's something that you don't need to be particularly technical to do. You don't have to be particularly technical in order to create real-time big data visualization. So this is updating in real time again. So if I was following any of you guys and you tweeted through here, this would update with your particular Twitter handle on it. Now I might want to add more things to this particular user interface up here. Oh, there you go. It's changing as we speak, which is kind of cool. So let's just go back to the standard search interface and look at a different visualization. Yeah, sure. Yeah. 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 No, you don't have to. Splunk will actually be able to join and correlate everything together. So we've got our Splunk search language, and one of the commands in the Splunk search language is called the transaction command. And this particular command is what you use for stitching together data from various disparate sources into a kind of cohesive transaction. No, that transaction stitching will be done in Splunk. You don't have to worry about stitching that stuff together. Yeah. If you're developing and you're creating the logs yourself, sometimes you're going to be responsible for the source of the machine data, sometimes you're not. So Splunk's got the power to be able to do those field extractions on the Splunk side, or if you're creating your log events at the source, put them into nice key value pairs to make it easier. And regardless, once all the data is in Splunk, it's Splunk's job to do the correlation and stitch your transaction together. You don't have to worry about that. You can correlate on many different things. You can correlate on a common ID. You can correlate on time boundaries. You can correlate on the fact that it started with this particular textual pattern or this regex and ended with this textual pattern or this regex. There's many different things that can define the bounds of a transaction for you to stitch together. So I'll just quickly add in one more visualization to this. So that's nice. It's a pretty pie chart. Or accounts by. All right, let's go have a look. Top hashtags. All right, put that over a real-time window. Whatever, I'll give that a 30-minute window. All right, so these are all the kind of top hashtags that have come through in the last 30 minutes. And again, this is real time. So I want to go and then take this tabular output and add that to the dashboard I just created. Again, hash tags real time. This one I've just put over a 30-minute real-time window, just because I can. And this time I'm just going to add it to an existing dashboard, which will just be the dashboard I just created. And I think the tabular view is pretty good for this. It looks okay down the bottom, so I'll go with that and just we'll see how this works. There we go. So you can see it's down the bottom and just waiting for the data to come in real time, and it should fill up this view. So you can see, there we go. And now it's automatically populated. And this is just going to sit here and update in real time. You see a lot of the content is now dropped off the top because obviously that sliding 5-minute window for the real time up the top has lapsed, and none of the people that I'm following have been tweeting. But I could go and very simply add in a new tweet right now for myself again. And just some simple hashtag there and tweet. All right, so I just sent one off, and hopefully we should see this pie chart update with Damien Dallimore in a second. There we go. That's my tweet that just came in. And the hashtag I put in, if you had looked really fast, the hashtag I actually put into the tweet was Splunk. So this is actually updated from 1 to 2 in the countdown here. So there you go. I won't dwell on that too much more. I'm limited by time. So that's just a very simple example. As you can see, the actual Spring integration Twitter demo app's just been churning away in the background, and as as new tweets have arrived from the people that I follow, they've been pulled down here and sent into Splunk. So that's basically it for that demo. Let's just head back to the PowerPoint slides now. All right, I got 5 minutes left, which is pretty good time actually. So given that this is a kind of Java and JVM crowd, I just want to touch on a couple of other little things that might be of interest to you. There's a couple of projects that I've created myself to help people using Splunk. So Splunk Java logging is a logging framework they created and put up on GitHub. The idea of this is to allow developers to, as seamlessly as possible, integrate the Splunk best practice semantic logging format into their code and transport their log events into Splunk. So what I talk about when I say best practice logging semantics is like those simple key equals value pairs, and actually getting your developers to really think about what is of value in terms of the log content that I'm generating and sending into Splunk. So rather than having to continually beat developers with a spoon and remind them to adhere to coding standards, I decided to create a framework. Frameworks are more reliable than developers sometimes. So this particular framework provides implementations of appenders for log4j and logback, and also a handler for people still out there using Java util logging for whatever reason. So you can very simply take these logging appenders and just plug them into your existing logging configuration to allow you to get your data directly into Splunk. It will just completely bypass a log file altogether, and your data will be sent into Splunk over either HTTP REST or raw TCP. There's also some helper classes and utilities in the Splunk Java logging framework to allow you to format your log events in this best practice semantic logging format, and also to handle stack traces a lot more elegantly and a lot nicer. There's loads of examples of this up on GitHub if you want to go up there and download Splunk Java logging and use it and play around with it. Again, entirely open source and entirely free, and you can basically do what you want with it. Another project I created is called Splunk for JMX. This is a Splunk-based app which you can go and download from splunkbase.splunk.com. And again, it's entirely free, and all the source code for this is up on JMX, is up on GitHub. But basically what this app is it allows you to monitor any JVM application and whatever's running in those JVMs as well. So it has out-of-the-box dashboards for all the kind of JVM level monitoring things you might be interested in, like memory and threading and garbage collection, and even through to some operating system stuff like CPU usage and file descriptors, memory pools, all the various metrics that get exposed out of the java.lang domain, mbean domain in the JVM. And then whatever else is running inside of the JVM, it's very, very simple to wire up your configuration to poll the various attributes and or invoke operations that those particular applications might be exposing. Supports all the kind of the main players out there in the JVM world: Hotspot, JRocket, OpenJDK, IBM J9. I haven't tried it with Azul Zing, but it should work because I believe Azul Zing's based off Hotspot. And again, you can use it to poll your various JMX attributes and operations. And the cool thing is you get to index these over time and utilize the power of the Splunk platform to use the Splunk search language to process all that data and get yourself some operational visibility into your JVM landscape. And then potentially correlate that with whatever other data that you might have residing in Splunk. Some application log files, some stuff that might have come in from app dynamics for real bytecode level tracing, HProf binary dumps that you might have rolled out into text to do some memory analysis, operating system level stuff so you can correlate what's going on in the OS with the actual JVM process. All this is machine data that you can feed into Splunk and use the power of Splunk to stitch this together to give you some very thorough JVM visibility. It's been designed in mind with large-scale deployments of JVMs, so a combination of the features of Splunk for JMX and the architectural features of Splunk allow this to be possible. I think Yahoo have something like 50,000 JVMs just in production for their Hadoop cluster, plus another 50,000 for their DR site. That's like 100,000 JVMs. So there are, the big data world and the Apache Hadoop project mean that there are customers out there with this very, very, very large scale JVM deployments now, and we need, I guess, a really decent big data solution to be able to provide operational visibility into this mass of machine data that needs to be monitored. It's completely extensible and customizable, and it supports many different connectivity options. Your standard kind of remote connection options out of the box with RMI and IOP, some of the MX4J HTTP connectors with Hessian, Burlap and SOAP, and you can also do direct process attachment if you require. Many customers actually do that. Again, freely downloadable from Splunk Base, all the code's on GitHub. You can use it, hack it, pull it apart, tweak it to your heart's content. That's the end of the content for the session. We have a booth outside, so you can come by that and just ask questions and get some answers. Can show you some more SDK code if you're really interested in that. We do have some t-shirts left. I think we've got some fresh stock that may have come in. A lot of them got pillaged very quickly on Monday night, which is great for you guys, but bad for our marketing department's budget. But we've still got a whole bunch left, so come by and try and grab some. And just a whole bunch of various contacts here if you want to get in touch with us regarding Splunk Base or the developer platform. Follow us on Twitter, email links. We have regional Splunk Live events that go on. If you want to know more about the product in detail, try and find one in your locale. And heaps of really cool online videos at the Splunk site, which will delve into very specific areas of the product if you want a deeper dive there. Again, all this information is on the slide deck that's on your USB key, so don't bother writing it down. And that's all I have for now, so thanks for coming along.